Hello my warriors, Vanakkam, welcome, bonjour, hola, namaskar, good evening, marhaba, Shruti, Muhammad, Rohit, and welcome all the NEET as well as the JEE aspirants who want to crack JEE or NEET this year. This is the Zero to Superhero series where we do quick revisions and mind maps and question solving along with the PYQs for your exam ahead. It's just few days and few weeks away from your exams, be it CUET, be it BITSAT, be it JEE, be it NEET or any other common entrance test. We need to buckle up, and like I have told you, I will be completing the entire 12th, whatever is remaining, because we have already done the term 2 syllabus just few days back. The term 1 syllabus done by May end, and then in the first few days of your June, your 11th standard will start, and we will try to finish it by June 10th, and then we'll just have mock tests. All right, so get up guys, welcome to Zero to Superhero series with me, Shreyas, your physics master teacher at Vedantu, and I hope you guys have smashed the like button and also hit the subscribe button. If you're not, you should do it right away, and make sure you have joined the Telegram channel as well. Welcome aboard all my lovely warriors. Let's just have a look at all of you, and there are a lot of important links that you can also see even in the description box while you are watching the video, like the JEE crash course and the NEET crash course at a discounted rate using my coupon code SHHPRO. That's in English medium, and also both they are separate for JEE and NEET with mock test assignments, everything. So go ahead, check it out. It's all there in the description box. This is your Telegram channel, this is my Instagram, all of it is there. Your Telegram channel. Nice to see all of you out here. Yes, this is going to be enough for NEET. Along with that, Mohammad, you should also go to the crash course. The combination of the crash course with YouTube works the best. Hi Hari Prasad, hi Achia, welcome. Hi Ravi Shankar, how are you guys? How is it going? And I hope you guys are going to prepare for JEE and NEET, even though your bio exam is around the corner, because this week, like I've told you, 12th standard term 1 syllabus done. Okay, so with me, hello Yuvashi, hello Shrikant, hi Zahin, hi Pooja, hi Shruti. Nice to see you guys. Hello Harish. So let's begin with the class, and the first thing that I'm going to show you is going to be very interesting, and that is basically your mind map. So today we are going to do the complete electrostatics and Gauss law part, and we are going to see lots of PYQs as well as problems on electrostatics and charges. So let's see this mind map. Okay, so let's see what is this mind map. Now these mind maps are very important before you attempt mock tests or even before your final competitive examinations. See, mind maps are different from formula book or short notes. Mind map is to recollect what are the different concepts in the chapter, and if you are not able to recollect it, or if you are not able to remember all those pointers, you should quickly open your short notes and check all the formulas, all the concepts, the definitions in that particular subtopic. So you should know what and all are the subtopics. You should make a map in your head, and you should rehearse it again and again and again, at least 10 to 20 times before your final examination. So in electrostatics, the main things that you're going to see is forces and their effects with dielectric materials. Then we'll move on to fields, then energies, potential and potential energy, work done, all of that. Dipoles is also a very important topic, and then of course the Gauss law and its applications along with the concept of the electric flux. So we are going to touch upon all these important pointers. This is your mind map for electrostatics and Gauss law, and yes Shruti, it is very cool. Dinkar Sengage is good enough. Yeah, no problem. Hi Darshini, and some Kannada or Telugu name also I can see. Hi, hello Harini, good evening. So let's start seeing all these pointers. Don't worry, you're going to get the PDF. Where will you get the PDF? Telegram channel. Keep this in mind. Okay, so let's start with it. And the first concept that I want to talk about is basically force, Coulombs law and all of that. So your Coulombs law is between the two charges. So if this is Q1 and it is separated by a distance of R with another charge of Q2, then there is a force between them. There is a force between them attraction or repulsion depending on whether they are like or unlike, that force is given by 1 by 4 pi epsilon naught q1 q2 divided by r square. It's an inverse square law, meaning when you double the distance, the force becomes 4 times less. If you make it 3 times, it will become 9 times less. This 1 by 4 pi epsilon naught has a value of nothing but 9 into 10 to the power 9 approximately in SI units, and this value that you see over here, epsilon naught, it is the permittivity in vacuum. Basically what happens is when you change the medium, then you will see the force also changes because of the polarization and all of that. The field weakens, and that is why you will see that you should modify this value when you change the medium. Sriji, I'm very good. Yes, I'll be doing a lot of questions, not some, many questions, Dixon. First, a quick overview because a lot of revision needs to be done so that you can make notes and you know what are the different concepts, and then questions, of course. If you are in some medium, then this should be replaced by epsilon naught of that medium is basically epsilon naught into K, where this K is basically your dielectric constant. This is for some particular medium. This is for some medium. Guys, quickly tell me, for air, what is the dielectric medium? Put it up in the chat box. Hi Hari Krishna, nice to see you back. What is the dielectric constant of air? Just put it up in the chat box before I turn around. All right. Now, that's all about forces that you should know. And let's slowly move to field as well. And then we'll again come back to forces. Don't worry. Yes, it is 1. It is not 0. Oops, it is not 0. Be very careful. Okay. For paper, glass, wood, etc., it is very good value. Like 20, 100, 50, 2, 4, 7. So these are the values for a dielectric constant. Usually it increases the capacity of a capacitor. Now talking about field, field is nothing but the force which acts per unit test positive charge. And can you guess the units of field? Epsilon naught value, Hari Prasad, the epsilon naught value, you can see it from here. So 9 into 10 to the power 9 is 1 by 4 pi epsilon naught. So epsilon, you can rearrange and get it. The value comes very close to 8.85 into 10 to the power minus 12. Okay. Now, if you look at the units, obviously force and charge. So Newton per coulomb, that is 1 unit. You can also use volts per meter. This is another unit. Very, very important. Coulomb, Newton per coulomb or volts per meter. Both units work. Some of you got it right. Very good. Hi, Vishnu. Okay, great. Next concept that you should know over here is that whenever you have a field, let's say this is basically a field line, and let's say for example, on that field line, you place a charge. You place a charge on it. What happens is that a force acts on that charge, and that force is given by charge into the value of the field. Charge into the value of the field, and this force is, in fact, the force is always along the tangent to the electric field line. Very important property of electric field line. The force on a charge which is placed is always going to be along the tangent. More the field, more the charge, more is the force. Is it possible that the force is anti-parallel to the field? Put it up in the chat box. Is it possible that the force is anti-parallel, exactly opposite to the field line? If it is, let me know. The permittivity of free space, Mohammed, I told you, 8.85 into 10 to the power minus 12. Okay, just move it around. Okay, think about it. Is it possible? Yes, it is possible. Think about it. How? If the charge is negative. If the charge is negative, for positive charge, it is in the field. Anti-parallel for a negative charge. Keep this in mind. Okay, so it can be opposite to the field. Yes, got it, understood, realized your mistake, no problems. Now, what happens when you have multiple charges? Let's say, for example, I don't know, maybe you have a charge over here, let's say Q1, let's say you have a charge over here, Q2, and so on and so forth, and you have a final charge Qn. Now, maybe I have a point here, let's say I call it P, and I want to find what is the net force or net field at that point. What you need to be aware of is something called as the superposition principle. What is it called? Superposition. Super duper principle. Superposition principle. So what does it say? It says that this point or this charge, let's say, will apply a field over here, let's say like this, E1. This charge might apply a field, let's say E2. This charge might apply a field, let's say, I don't know, En. So the vector addition of all of them, the vector addition, I don't know, maybe it is like this, maybe it is like this. So this is basically your all the vector sum. So this will be basically your E1 bar plus E2 bar plus En bar. So it is a vector addition. Electric field is a vector quantity. So you need to be very careful. You need the knowledge of vectors, resolution, components, addition, subtraction. If you are well versed with it in 2D as well as 3D, including the formulas, triangle law, polygon law, parallelogram law, then you will be comfortable with these kind of questions. Is that okay, guys? Fair enough. Let's move on. Now, there are some interesting properties of the electric field lines. One of them being the force is always parallel or anti-parallel to the electric field line. The second concept is no two field lines can ever intersect. No intersection allowed. No intersection. Intersect. So there is no possibility of intersection at any point, because if they intersect, then at that point there are two different directions of forces, which is very, very confusing. Is it this way or is it that way? Because the tangent gives you the direction of the force. So that is not possible, like I have told you. Also, if the field lines spread maybe like this, then the field where it is weak, you will see the lines will be away from each other. So here it will be weak. Here the field will be definitely very, very strong. Keep this in mind. The field will be strong here. Here it will be very weak. No, Deepa, we are going to do the problems today only with PYQs. Initial part of the class will be revision, concepts, mind map. This mind map, we are going to discuss all these points quickly. It's not going to take a lot of time, don't worry. And then we'll go to quickly the problems as well as the PYQs. Can the force be ever perpendicular? Never, Shruti. It will be only parallel or anti-parallel. Only along that field lines only, nothing else. Okay, this is something which is very important. Another important pointer which you should know is that whenever you have an electric field line, it always goes from a high potential to something called as the low potential. Always high voltage to low voltage. Any kind of field line, be it magnetic, gravitation, electric, everything. 1.5 hours, Shreyas T. Okay, so this is another important pointer which you should know. And another important pointer is that inside a conductor, the field is 0, and just outside the field is perpendicular to the surface. Just outside it is perpendicular to the surface. You would remember, if you take a sphere, it comes radially out. If you take some random shape, it is always going to be perpendicular to the surface. Keep all these pointers in mind. Okay, so we have discussed quite a few things about force and field and superposition, and even the dielectric constant. We will see also the dielectric field, we will also see the field due to many geometries after some time, don't worry. Now let me bring your focus to potential energy and work done. Next important concept. Sir, on the surface of the sphere, what is the electric field? I'll come to that. We will be taking all the geometries, Janaram, inside, outside, everything I'll be giving you, Janaram. Okay, let's move on. Now, the next concept that you should know is about basically potential energy. So, talking about potential energy. What is the symbol, guys? Put it up in the chat box. Before I complete the diagram, come on, I want your answer. What is the symbol of potential energy? Simple, one symbol. Q2, 2 charges. Q1, Q2, 2 charges. The formula is nothing but, again, 1 by 4 pi epsilon naught. Q1, Q2, but it is not R square, it is just R. Yes, it is U. Very good. You are correct. Perfecto. Can potential energy be positive or negative or only positive? Put it up in the chat box. Is it always positive? Is it always negative? Or it can be both of them? Come on, let me know. Okay, and remember, potential energy at infinity is going to be 0. So U infinity is 0, something which you should know of. It can be both. Very good, Tanra. Excellent. All right, excellent. It depends on the values. If both are positive, both are negative, it is positive. One of them is negative, one of them is positive, negative. Very good, excellent. Now, if you rearrange these particles, you will see the energy also changes. And sometimes you can have more than 2 particles. Example, 1, 2, 3, 4, get on the dance floor. Okay, so you have multiple particles. If you want to find the energy of the system, you will take it in pairs. This with this, 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 this with this. All the pairs possible. So that will give you the potential energy of the system, which is the sum of all the potential energies of the pairs of the charges. Keep this in mind. Yeah. Yes, MV ready. You can put it up. If it is related, definitely I will help you with it. And if you rearrange the system, let's say you change this. You take one of the charge here, you take this charge here, you take this charge here, this charge here. So basically you change the position, you change the arrangement, you basically change anything. Let's say a sphere is brought close to a ring, a point charge is taken close to another charge, the charges are separated, there are 4 charges on the sides of a square, you expand the square, anything, change the arrangement. If you change the arrangement, then what will happen? There will be a change in the potential energy of that system, which will be given by final minus initial energy. So in order to change that energy, you will have to do some work externally. So only when you do work will the energy change. That's something which you should keep in mind. Okay, NC2 formula pairs. Yes, Hari Prasad. Okay, exactly. That's what I'm doing, Deepa, right now. High yield topics. Deepa, you have a lot of time. Don't focus on just important topics. I mean, like not very, very important. Focus on all the important topics. Okay, because still you have 1.5 months or even more. Okay, very good. Now, we will also move to potential and then come back to potential energy in a bit. So talking about potential, what is the symbol, guys? Before I complete, come on, what is the symbol of potential? So if you have a charge, and if you are at some distance, you will see that the potential is given by K, Q by R. Symbol is V. Very good. We are correct. Last time you were correct, now we are correct. And the unit is obviously volts, and the way it has been defined is the work done per unit test positive charge, to bring from infinity to any particular point. That's how it works. Very good. Now we had electric field, we had electric field lines. We talked about potential. So we are also going to have equipotential lines. Imagine there are some points which have the same voltage, same potential. If I join those points, that is called as an equipotential line. And all the points will have the same voltage. I can have many such lines like this. So maybe this has voltage V1, this has voltage V2. These points are at some voltage, these points are at some different voltage. Now here is what I do. Imagine I take a charge. And let's say the value is Q, and I move it like this. And I place it over here. So think about this as if this is its initial point, this is its final point, this is the path taken. You will see the charge has gone from one potential to the another potential. So definitely between these two lines, there is something called as potential difference. It is again measured in volts. So this is delta V. So if you take the charge from here to here, from one potential to another potential, what are you changing? One potential to another potential. If you take a charge, You are changing its energy. Which energy? Electrical potential energy. So that change in the electrical potential energy is given by the value of the charge into the voltage difference. Value of the charge into the voltage difference gives you the change in the electrical energy. Yes, potential also can be positive as well as negative, Krishna. Perfect. Delta U, Janaram, is the change in the energy. Change. This delta U is basically your change in electrical potential energy. Is that fine, bacha? Okay. Alright, silver pills, maybe some other time I'll tell you about all those things. Okay, but yes, I do listen to little bit of classical, but not so much. Okay, now moving on to the next pointer over here. Since we are talking about equipotential lines, more pointers that you should know is, if you have equipotential lines like this, potential V1, this is potential V2, if you draw perpendiculars to them, okay, perpendiculars at every point, these will be your electric field lines. Always the perpendicular to electric field is potential, perpendicular to potential is electric field. Very, very important. Keep this in mind. Also, one more interesting result between electric field and potential is this one, that is, electric field is the negative gradient of potential. This is very important line. There are a lot of questions on this. So it is basically minus dV by dr. You differentiate it, you get the answer. E is minus dV by dr. All right. Yes, we are going to do NLM and friction. We are going to do a superhero series lecture, definitely, Janaram. Current electricity, infusion batch, but can't watch due to math exam. Oh, no problem. Watch the replay, Harshavardhan. Okay, so let's move on. Is NCERT enough? No. Solve PYQs and mock tests. Okay, so now that we have spoken about potential difference, everything, one last thing which you might need in certain problems is, you might need energy conservation. So certain problems need energy conservation, where some charges are taken from one point to the other, some work is done, initial energy is there, final energy is there. So there you will use obviously initial energy potential plus initial kinetic energy will be final potential plus final kinetic. One of the most classic examples of this is basically you take a charge of value q and mass m, and you basically accelerate it via potential difference delta V. So by the time it reaches here, it has some speed which is u. So u is basically the speed. The classic equation for this kind of a question comes out to be basically nothing but the energy change. The energy change is basically the charge into delta V is equal to the gain in the kinetic energy, which is half mu square. Very classic equation used in even modern physics, you might remember. Yes, to be very precise, it is actually the partial derivative with respect to x plus partial derivative with respect to y plus partial derivative with respect to z, I cap, j cap, k cap. True. Yes, Yogita. Oh my god, 281 by 300. Nandita Tripathi, that is very good. That is very good, bacha. Okay, so that's about your potential, the work, energy changes, etc. So we have covered a lot of pointers here. Coming to the geometrical aspects in a bit, don't worry. Now we'll move on to some electrical dipoles concept. Let's move on, guys. Okay. So yes, MV ready. It is a little bit in that range only, 150 to 160. Okay. Now, what is a dipole? Dipole is basically a positive charge and a negative charge together, separated by some distance, let's say L. So negative and positive charge like this. That is a dipole. So the dipole moment is basically the charge multiplied by the separation. So the charge is, let's say, q. This is minus q, this is plus q. So P is the value or the symbol, Q into L. Some books use 2L. Guys, here the total length is L, so I put L. Some books write L plus L, 2L. Why unnecessarily put L? No, it's simple. Okay, can you guys tell me the direction of the dipole moment? From where to where is this? From where to where is the dipole moment? Is it from positive to negative or negative to positive? Hello, Yogesh. Positive to negative or negative to positive? Think about it. The field lines, by the way, come like this. This is how, you know, your field lines will look like. This is how it should be shown. Okay, coming out like this. Perfect. So there'll be more field lines, but I don't have so much space. I hope you remember that diagram. It comes in like this. It's always from negative to positive, not positive to negative. Field comes from positive to negative. Dipole moment, this dipole moment, it's a vector quantity, always from minus to plus. Keep this in mind. Very, very important. Okay, from minus to plus. Remember that. Very good. Excellent. The series has started, in fact, before your this thing board exam, Suhani. I completed the term 2 syllabus because that was needed for your board exams. Now, since the term 2 syllabus is done, we are going to focus on term 1 syllabus of 12th in this week completely. Okay, so before May end, your term 1 syllabus is also done. So 12th is done, and in the June first 2 weeks, your complete 11th is done. So complete holistic revision and then mock tests, PYQs, and all other kinds of series. Yes, MV Reddy. Yes, but that was for girls quota, if I'm not wrong, MV Reddy. Gaji, you're a little bit late, but it's okay. You can just join in right now. Now, there are 2 points which are very important. First point is over here. This is called as an axial point. And the second point is right over here. Okay? This is basically called as the equatorial point. And a general point is, let's say, over here at a distance r. This is angle theta. If you notice, on the axial position, theta is 0. On the axial position, theta is 0. And on the equatorial position, theta is basically 90 degrees. Now, if you are at this particular point, I am interested to know what is the field, what is the potential, etc. We'll come to that. But before going ahead, remember one important statement. Electric field at the axial position is twice the electric field on the equatorial position. Very important. Here the field is strong because many lines are there. After they get distributed, it becomes very weak. Something which you should always remember. Now, for a general point is something which is worth noting. So electric field at this general point and the potential. Let's write it down. It is nothing but K, which is your Coulombs constant, into P, which is your dipole moment over here, divided by R cube, and here you will have root of 3 cos square theta plus 1. Very important formula, and the formula for potential is basically K P cos theta divided by R square. So guys, can you tell me, where is the potential 0? Is it on the axial or is it on the equatorial or nowhere? Enlite's product, oh my god, what a name. Yes, Chitra, I'm going to do NLM 11th standard syllabus starting from June 1st. Yes, it is at equatorial because cos 90 is 0. So you can see that theta is 90 only on the equatorial region. Very good. My blessings are always there to everyone, MV Reddy, who are attending the classes, who are sincere, who are working, solving all the questions and putting all their efforts and dedication over here. Now, the next part is, see, this was the field and potential due to a dipole. The next concept is dipole in somebody else's field. So just maybe imagine that there is a electric field, maybe something like this. It is some external field, and again you take this kind of a dipole. So let's say this is your dipole, this is P, this is making angle theta, obviously this is positive, this is negative. We know that there will be force acting due to the field on the positive negative charges. There will be a force here there will be a force here. So because of this, what is going to happen is that the net force will cancel out, it will be 0, but this force will produce a couple. So this torque is a couple torque, and it will come out to be P cross E vector. Magnitude wise it is P sine theta. So magnitude wise it is just P sine theta, and it is maximum when P is perpendicular to E. So this is the torque acting. This is basically your couple torque. Couple torque, because two forces equal and opposite is called as a couple. Hello MK. Okay, Tanush, capacitance is going to be tomorrow. Okay, now definitely Gaji, Shruti. Wow, very good. I'm so happy you covered all the topics. Very good. Yeah, you guys are making the best use of all the resources available to you. God bless you guys. Last concept over here is potential energy. Potential energy is given by minus P vector dot E vector. This is a dot product, so you can also write it as minus PE cos theta. And guys, potential energy is maximum. Potential energy is maximum when theta is how much? Come on, put it up in the chat box. Yeah, Enlite's product. I'll be doing the 11th standard topics in June, first week. Okay. And theta is 0, 90, wrong. Guys, it is 180, think about it. Cos of 180 is minus 1, minus minus becomes plus. If you put 0, cos 0 is 1, it will become negative, negative value is smaller. So this value is maximum when theta is basically 180 degrees. This is basically your unstable point. This is your unstable point, and it is minimum when it is stable, and that happens when theta is basically 0 degrees. Be careful. Yeah, so a lot of people make a mistake because of that minus sign. Very, very crucial. Okay, so we have spoken about dipoles, we have spoken about the field and the effect of field on a dipole. So many nice notes, guys. I mean, somebody gave me all these notes now. I would be so happy. First of all, I will definitely smash the like button. If you have not done it, that means I say you are just watching. Very bad. Okay, next thing we will see. Okay, Gauss's law, and then the fields and potentials due to all the other geometries. All right, so let's start with it. Yes, Gauss's law. So just imagine, let's say we have some charges Q1, Q2, Q3, and let's say this is Qn, and I draw a surface. This surface is a closed surface. Closed surface. Any closed surface is called as basically a Gaussian surface. Any closed surface is called as a Gaussian surface. Closed means there is no opening. There is it's completely covered. So why force is possible only when non-uniform field is there? Because Janaram, then the forces won't be equal and opposite because it's non-uniform. Here the force is different, here the force is different. So they will not cancel, and hence the net force will not be 0. Okay. So 0 to superhero for rotation. Yes, Enlite. In June only, first week, the 0 to superhero will focus on 11th standard topics. Alright. Now imagine there are some other charges. Let's say I call it capital Q1, capital Q2, capital Q3, capital Qn. These are the charges which are basically inside the surface, and these are the charges which are basically outside the Gaussian surface. So that's why you need a closed surface, because if there is an opening, there is nothing like inside and outside. So we know charges inside is different from the charges outside. Okay, we'll keep this aside. Now going back, imagine I take a surface, and this is my surface. I define a quantity called as the area vector. Area vector is always perpendicular to the surface. So if my hand is a surface, a perpendicular drawn to it, that's the area vector. So the area vector for this surface is this one. The length depends on the area. If area is small, the vector is small. Area is big, the vector is big. And let us just say that there is some electric field which is cutting through it. So we define something called as the flux. Flux is basically the flow of the field lines. And this electric flux quantity, symbol is phi. You can put E to be sure that yes, it is electric, is given by electric field vector dot area vector. So it will be basically E A cos theta. So this is the value of the electric flux, which tells you how many lines are piercing through a given area. So guys, quickly tell me, when is flux maximum? When do you think is flux maximum? Come on, put it up in the chat box. This flux will be maximum when the field is theta is 0. Yes, the field is basically parallel to the area vector, but when this happens, field is perpendicular to the surface. Understand this concept. Very important. A lot of people get confused here. When this surface becomes like this, you will see the area vector is here, even the field is there, angle theta is 0. Theta is 0. This is theta. This is theta. But when that happens, field is perpendicular to the surface. Understand, surface is perpendicular to the area vector. They are two different things. Understood, guys? So yes, theta will be 0 degrees, but surface wise it will be perpendicular. Area wise it is parallel. Area vector wise. Do you guys get it? Everybody with me on this? I'm so glad. Foundation biology classes. So happy. Okay. Very important. Okay, now coming back over here. According to Gauss law, what did this dude say? This dude said one simple thing. What was his simple thing? He said the total flux from a closed surface is basically given by whatever charges are given inside. You just add them up and divide it by epsilon naught. Now if you notice here, Q capitals are outside, so don't bother. The small q's are inside, the one in blue. So Q1 plus Q2 plus Qn divided by epsilon naught. Now this is the flux through the closed surface. Please keep this in mind. Electric field lines will be variable. It will be there everywhere. These are your electric field lines. You guys only quickly tell me, this electric field over here, is it because of only inside charges, or is it because of outside charges, or is it because of both of them? Come on, recollect and tell me. So flux does not depend on the medium. So if you basically change the medium, what will happen? The net flux will also change because the field will weaken. Field will get weakened. Only inside? That is completely wrong. It is both because of inside. It is because of both inside as well as and outside charges. It's because of both. It's because of inside as well as outside charges. Very, very important. Think about it. At this point, the electric field will be because of this, everything. But the net flux, when you calculate the net flux, it only depends on the inside part. So the interesting thing about Gauss's law is that the RHS is dependent on the inside part. The flux is a calculation of all the electric field into area vector, electric field dot area vector throughout the surface, where the field is because of both inside as well as outside charges. And because the field is variable over here, you need to integrate, because this point, everything field will be different. So integrate electric field dot small area vectors. But since it is a closed surface, what do you need to do? Since it's a closed surface, you are going to put a cyclic integral. This tells you it's a closed surface. Okay. One more important thing which you should know is, somebody was asking, is flux positive or negative? Let me also mention that. So just maybe I can put it over here. So if this is a Gaussian surface, please keep this in mind. Very, very important terminology. If a field line is coming outside, it is positive flux. And if a field line is going inside, this is basically negative flux. This is your sign convention. Yes, so flux can be positive or negative, based on the signs. Cyclic integral SKS because cyclic means covering everything. It's just symbolic of telling you don't leave any area, or else you might just think, oh, you have to just add the areas for any random shape. No, that area has to be completely closed. That's when Gauss's law is valid. Is that okay? So that's what it is. Harsh Delhi wala, oh my god, what is Gauss's law? Gauss's law is exactly this. The net flux enclosed is the net charge inside upon the epsilon. This is exactly your Gauss's law, bacha. This entire thing over here. Okay, so I'm not sure, Harsh, if you are in the 12th standard right now or you're passing out, please check that out. Because if you're just entering 12th standard, then maybe you need to watch my detailed classes, which is there in the Pathfinder playlist. Yes, number of flux entered is number of flux goes out Vaishal FF, then net flux will be 0. Okay, last point over here, and that is basically we have covered almost everything. We are now going to focus on the fields and potentials for different geometries. So this is the most important part. Do not ignore this. And then we are going to go to problems. Let's start. Starting with the first geometry, which is basically your shell. Very important geometry. The shell has a radius of r. The charges are only going to be there on the periphery. The charge is q. So talking about the field and the potential. Field, first thing. Field, again there are 2 points here. One is inside, one is outside. Capital R is the radius of the shell. I will also use a symbol called as small r. Small r is the distance from the center to that particular point where you are finding the field. So it will be nothing but 1 by 4 pi epsilon naught q divided by r square when you are outside. So this is like a point charge. So when you are outside, this entire shell behaves like a point. So that's why you get this formula. But when you are inside, it becomes 0. Very crucial. All the fields cancel out each other. Oh, Harsh, you're going to give the exam this year or next year? That also matters. Okay, potential wise, again when you are outside, it behaves like a point charge at the center. So it will be 1 by 4 pi epsilon naught q divided by r. So this is when you are basically outside. The same thing when you are inside. It's very interesting. Remember this, it's basically q by r. This r is the radius, this r is different. Be careful. So this is when you are inside. It just tells you that it is constant everywhere. Everywhere it is going to be constant. Very crucial. If you talk about the graphs, well, the graphs will probably look like this. For field, inside is 0, outside it changes. So this is field versus distance. It will be 0 and then it goes up and comes down. This is how it looks like for field. If you talk about potential with distance, it is constant till radius r, and after that it starts dropping. This is how the graphs will look like. Okay, so keep this in mind. Very important. Abhijit, it comes via Gauss's law. If you take a Gaussian surface inside, charge inside is 0. If charge inside is 0, you will see that RHS is 0. If RHS is 0, LHS is 0. If LHS is 0, E is 0. That's how the working is. You can check out the derivations in detail, which is there in HC Verma. Or you can also check out my lectures of either 12th standard or on the platform. Shell is like a hollow sphere. Yes, shell, hollow sphere means the same thing. Okay, fair enough. Now moving on to another geometry, maybe we can take up a, I don't know, maybe a ring or something, and then I'll go to solid sphere also. So for a ring, so this is a ring, and again it is, let's say, charged. All right, this is the radius of the ring. This is the radius. This is the axis of the ring. This is the axis of the ring. So again, you will get two things. Electric field on the axis of the ring is given by 1 by 4 pi epsilon naught standard q, and here you will have x. X comes in the numerator because I know if this point is over here, that means x becomes 0, then the field from everywhere will cancel out. The answer should be 0. So I need that x on the top. That's how I remember that x is there. And to satisfy it dimensionally, I'll just write it as r square plus x square whole raised to 3 by 2. because eventually you should get r square in the denominator. So you can check dimensionally 1 meter, square and root cancels, so cube is there, 1 meter and cube r square will be there. That's how you can check it out. Okay, and similarly you can also draw the graph of the field over here. It basically goes up, it basically starts from 0, it goes up and goes down. You should know this value, it is maximum at r by root 2. This is a graph of field versus x. Very important graph, and you should also know where it is basically going to be maximum. There could be questions also on that. There have been times where they have asked it. Potential wise, it is just simply put 1 by 4 pi epsilon naught. All the charges are same distance, so it just comes out to be q divided by just root of r square plus x square, which is basically the hypotenuse. So this is your root of r square plus x square. That's it. Okay, if you talk about the potential graph, well, that's simple. That potential graph just goes up and comes down. This is potential versus distance. If it is negative, it will come down. Keep that in mind. Is that okay? SKS, I think you have a chance, but start studying now. Hello, Ravi Kiran. Okay. Yes, you have to find the maximum value by derivatives, maxima, minima. First, d by dr is equal to 0. Then second derivative, you will check it. If it is negative, yes, that's a maxima. That's how it is done. Okay, moving on to the next geometry, guys. Moving on to the next geometry, let's take up a solid sphere, which is uniformly charged. Uniformly charged sphere. Uniformly charged sphere. So charges are not just there on the surface, but they are also there inside of it. And again, the radius is r. Okay, the charge totally is q. Okay, again, two cases, guys. Let's start with it. First thing, electric field. When you're inside, it is proportional to r. That's something which you should keep in mind. So it will look something like this: 1 by 4 pi epsilon naught q divided by r cube and here r. Because it is proportional to r, to satisfy dimensionally, make it cube. So the net dimension of length will be square. So this happens when you are basically inside, and when you are outside, then it becomes 1 by 4 pi epsilon naught q divided by small r square. It basically behaves like one point charge, as if all the charge is concentrated here. So that's when you're completely outside of it. Now, if x is smaller than r also, yes, you can use it. For which one you are saying? Dixon, the previous one, x? Yeah, you can use this one also. Now, talking about potentials, guys. Potential wise, it is just given by 1 by 4 pi epsilon naught q divided by, be careful when you're inside. When you're inside, what happens is you get 3 and you will get r cube here. Oh, sorry, not 3, you will get 2, my bad. Just one second. You will get 2 r cube over here. So 2 and 3, inverse it. So you put 3 and then you put r and you square it. Look at this, 2, 3, 3, 2. That's how you're going to remember it. And always you will be like, sir, what if I forgot where is the cube, where is the square? Obviously, it's potential. Dimension of length should be there below. So higher power should be there below, lower power should be there on the top. So 3r square minus a small r square. That's it. That's how the formula looks. When you're inside, it's slightly complicated than your usual formulas. When you're outside, it is simple. It is just 1 by 4 pi epsilon naught q divided by r. When you're outside, it just behaves like one single point charge. That's it. For ring, yes, you can use it anytime. Yeah. So Janaram, x is up because you want to make sure that first of all, when x is 0, E will be 0, because I know if you're at the center of the ring, everywhere the fields will come and cancel out. So the formula should be such that when you substitute x is 0, it should become 0. Okay, hi James Buck, nice to see you back. So I hope all these formulas are noted down, as well as this formula is noted down. As a solid sphere, it's done. Alrighty guys, so let's move on to the next one, and maybe we can take a uniform sheet. So uniform sheet which is charged So it has sigma, which is basically Coulomb per meter square. It is area charge density. You will see that the field will be uniform. This is uniform field, and that uniform field is given by sigma by 2 epsilon naught. Very, very crucial. Very, very crucial, guys. Okay, very important formula. Okay. Next important formula. Maybe we can take something else. What else is remaining? Maybe a line charge. Yes. A line charge. So this is your line. This is charged. These are the major things which you should know. And lambda is the linear charge density. Basically, it is in coulombs per meter. Coulombs per meter. And let us say you are at some distance r at this particular point. Now you get two components of the field right over here. Observe it. Very, very crucial. So let us say that this extreme end and this extreme end make some angle alpha and beta. This is alpha and this is beta. So what you get over here are the two components. Observe the two components carefully. One component is the perpendicular component. The perpendicular component to the line charge, that is given by, observe this, 1 by 4 pi epsilon naught lambda by r square. Lambda by r square. Here, sorry, not r square, my bad. Lambda by r, because lambda already has a dimension of length. So in the denominator, it's Coulomb per meter. So don't have to worry about it. So sine alpha plus sine beta. Very crucial. So say for example, if it's an infinitely long wire, alpha and beta will expand so much that both of them will become 90. So you will see alpha and beta both will be 90 degrees. So that electric field which is there, it will come out to be nothing but 1 by 4 pi epsilon naught lambda by r sine 90 plus sine 90, which is 1 plus 1. So it will become lambda by 2 pi epsilon naught r. So this is the field for an infinitely long wire. Very similar to one in magnetism. Okay. You can also find out the parallel component. Sometimes it could be useful for JEE advanced type of questions. The parallel component will be similarly given 1 by 4 pi epsilon naught lambda by r. Here you will have cos alpha minus cos beta. That is the formula. That's the only change. Nice to see you, Abhishek. After a long time. Hi, Sugant. Okay, keep this in mind. One more formula which I can also tell you right now is this one. If you have, okay, I'll put it here maybe. If you have an arc, if you take that wire and bend it into an arc which has lambda, again linear charge density, Coulomb per meter, and let us just say that the arc subtends some angle theta and radius r, then the field, then the electric field is exactly on the angle bisector. Electric field is exactly on that angle bisector, and that electric field is just given by 2k, k is 1 by 4 pi epsilon naught, lambda, and divided by r, and here you have sine of theta divided by 2. So that is the formula which you should know. 2k lambda by r sine theta by 2. Good evening, TNMIFC. These are do and die chapters only, Abhishek. Oh, you want the list of the do and die chapters? Definitely, I will put it up in a video. Definitely, in, just give me a few days. Hi, Deepti Mohan Rao. Okay, hi for me. Oh, hello, SKS Gaming. I think I wish you hello a long time back. Good morning, Jamesburg. Where are you from, Jamesburg? Are you not in India? Okay, so all these formulas done. Can we start questions? Give me a high five, give me a thumbs up. Put up a smash on that like button right now. Done. This is our theory. So a lot of concepts done. So very important pointers, formulas, all my handwritten notes will be available on the Telegram channel. Remember, this is our Telegram channel. Make sure you join it. Okay. Now let's start with questions. Mind map is also given. So let's begin with our first question coming up on your screen. Sriji, there will be a question on that last formula in a bit. You will see the revision of it. Okay. Casual session, Shruti. I wish I can conduct casual session, but honestly, I hardly have any time because I'm right now on two channels. One is NEET Made Easy, where I'm teaching in Hindi, and this channel where I'm teaching in English. So JEE NEET students, exams around the corner, 10th moving to 11th. So many things are going to come up. Plus my regular batches are also going on. So guys, it's going to be a little difficult. I'll try to make up time, maybe in the days to come. I don't know. I can't assure you right now. Yeah, the notes and all are free Dixon on the Telegram channel. Okay, option C, is it? Come on, I want the spam. Goxter also saying, Draw and Draw also saying C. Very good. Proud of you. This is exactly your Gauss's law. What was Gauss's law? The flux through closed surface is the net charge enclosed by epsilon naught. This is exactly what the statement C says. Everything else is wrong. Gauss's law is even valid for other mediums. Gauss's law is only valid for symmetrical. Wrong. None of the above is correct. No, this is correct. What about this question? There are two charges. Try to work it out. Very good. Most of you have got it correct. There are two charges like so, and there is some force F between them. Now you touch the charges, separate them, keep it at the same distance. What's going to be the new force? Think about it. You have two charges. This is plus 10. This is minus 90. There is some distance. There is force between them. Force will be magnitude wise. K into Q1 into Q2 divided by R square. Now you touch them. So when you touch them, obviously the total charge will be minus 90 plus 10, which is minus 80, and you separate them out. So when you separate them out, you are going to see again the charges will get equally distributed, minus 40 and minus 40, same distance. Touch, total charge minus 80, split, equal charges, so minus 40, minus 40. So the new force magnitude will be K, Q1, Q2 divided by R square. So I think we can just divide both of them. Let's see what do we get. F1 by F will be K, K gone, R square gone. So I will be left with 40 into 40 divided by 10 into 90. So 0, 0, 0, 0 gone. 4 4s are 16 by 9. So F1 should be 16 by 9 times of F. That's the answer. Check this out if this makes sense. C once again, C for cat 2. Amazing. Very good. C for cat. Yeah, very true. C for cat. Excellent. Let's move on. Which of the following statement is correct regarding the dielectric materials? Which of the following is true for a dielectric material? Dielectric material, you should know what it is, only then you can get the answer. Come on, think it. Only an electrically insulating material can be dielectric, only a conducting material can be dielectric, both insulating and conducting material can be dielectric, none of the above. Oh, a lot of you are saying C, some of you are saying B, and one of you is saying A also. Wow, we have variety of kids. Wow guys, Janarama, looks like bacha, you are correct. And also Sriji is correct. Very good, proud of you. So dielectric means when you apply some external electric field, then that material which is there, the dielectric material, it will get polarized. You will see that positive, negative, polarization occurs. This is your polarization. But there will be no current in it. So current will flow, will be zero, because of which it should not be a conductor. It can be only insulating, and that is why it is called as dielectric. Keep this in mind. So Guys, understand dielectric material is something which can get polarized on the application of electric field, and that is why the field inside becomes less. So you should know the real working of how a dielectric material works. In case you have forgotten, please check out my playlist. It's all there on our channel. So in case you have forgotten where the playlist is, please go ahead. So it's there right now. Also, just go down, go down, go down. Okay, do you see this is 11th standard? Similarly, we have a 12th standard. You can see physics. Click on this, all detailed classes, electrostatics. Look at this, everything. Backlog clearance, flux, finding of field, plates, Menti quizzes, everything for all the chapters, guys. All the chapters it is there. You should definitely check it out if you have not yet checked it out. Wow. Sir, when will you start class 11th portions? You mean in 0 to superhero? In 0 to superhero, June. And for the other students, I'll be doing something in just few days to come. Don't worry. Backlog, Janaram. Channel him, Harini. Oh my God. Come on, please help Harini. Janaram, backlog means something which you have not done. It's remaining. That's the meaning of backlog. Okay. Let's move on to the next one. Channel is this one only, bacha. This is the same channel where you're watching it. Okay. Let's move on. There is a spherically charged conductor sigma is the charge density. The field on its surface is E. If you increase the radius, double it, same density, then what is the new field on the surface? PYQs are not enough, but they are mandatory. It's necessary, but not sufficient. That's the condition. So we have a charged sphere like so. This is, let's say, the radius. There is electric field everywhere like this on the surface. What is this electric field given by? Standard formula. Your 1 by 4 pi epsilon naught Q divided by R square. Let's rearrange this. So I'll write it as Q by 4 pi R square and 1 by epsilon naught here. So this will become just Q by epsilon naught. This, sorry, not Q, my bad, sigma. Sigma is your surface charge density. Sigma by epsilon naught. This is very crucial because if you read the question carefully, you will understand it here that keeping the surface charge density unchanged, that means sigma is basically same. E is independent. It's independent of the radius. So even if the radius is doubled, it has no effect on it. Hence, you will see electric field will still remain the same if density is same. Hence, the answer should be C. This time you guys are lucky. Yes, option C. Okay. Telegram is working. Didn't get any message, meaning Dhanush, I didn't understand it. Please explain, what are you saying? Is Telegram working or not working? Which message you did not get? I'm not able to understand. Please tell me. Wow, we have a beautiful question now. Let's see. So charges are there. Q, 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 minus, minus, minus. Hexagon, side A. And you are on a point which is on the perpendicular of the plane, on the axis. So from point O at this point, you are present. The question is, what is the field? What is the electric field at that point? Just to give you a visualization of this, maybe I can put it over here, something like this. Oops, sorry. Just 1 second. Just think about it. You are over here. This is basically X. This is that point. So think of it basically like this. You are over here. Visualize it in 3D. Are you able to visualize it? Okay. How are you, aspirant? My favorite color, blue. Now, if you think the answer is 0, you're wrong, obviously. Okay? Because all the charges are not equal. So they will not cancel out for sure. Instead, we can make couples. Yes. Plus, minus. Laila, Majnu. Heer, Ranja. Pandu, Champa. Couples are there. Positive, negative, positive, negative, positive, negative. So for these couples, or basically dipoles, which we call them, if you are here, just forget everything else. Let's say take two dipoles. This point is what kind of point? Visualize it. This is a dipole. Field lines will come like this and go inside. From this or this, it will come like this and go inside. From this, it will go like this and go inside. So for this dipole or this dipole or this dipole, let's say you take this dipole. So if you are at this point away from the plane of the board, what is that point? It's not axial, it's equatorial. It is equatorial. Think about it. The field will come like this. This is axis. Here, offset, you are equatorial. Is that understood? Couple means positive, negative. Positive, negative. Yeah, no force is acting. I'm not saying couple force. I'm just saying positive, negative wise coupled charges. All electrical symmetrical shapes have zero? No, that is wrong. No, even if all the charges are distributed and you are on the axis, the field is not zero. Take the example of a ring. All the charges are distributed, you are on the axis, the field is not zero. It is there. It's only zero when you are at the center. Be careful. Okay. So because of this and this, if you go like that, the field will be here. The field will be here. Let's say I call it E1 because of this and this. Because I know that a positive and a negative charge will give a field like this. Will give a field like this. So the field will be exactly opposite like that. Everybody with me on this? This is your equatorial point. Equatorial point. Same thing for this and this. Is the same two charges rotated? Same two charges rotated. So if you rotate these charges, you will see an electric field over here, E1. And the same two charges rotated like this, you will see an electric field E1 like this. Got it? Now tell me what is the angle over here. What is this angle? Quickly tell me, because then we can find out the net electric field. You can find out the net electric field. Come on. The angle is going to be, revision के लिए ही है IIT aspirant. Yes, it's going to be 60. Yes, this is exactly going to be 60 degrees. It's a hexagon. So the net electric field will be the sum of all these three things. I feel E1's cos 60 component should be taken. E1's cos 60 component should be taken, and this E1 should be taken as it is. There are three vectors. One vector here, one vector here, one vector here. Why will you take only x components? Think about it. Why will I not take sin 60 components? Put it up in the chat box. Why will I not take sine components? Think about it. Because the sine components will get cancelled. This guy's sine component and this guy's sine component will be equal and opposite. They will get cancelled. So only cos components. So it will be E1 cos 60 plus E1 plus E1 cos 60. So this will become E1 is there many times, half plus 1 plus half, which is basically twice E1. Now what is the value of E1? This is at equatorial position, so you just use the formula for equatorial position, which was K into P divided by R cube. Now in this case, what is this value? Think about it. K is nothing but 1 by 4 pi epsilon naught. P, equatorial. Okay. By the way, the dipole moment is going to be charge into the separation. Separation is 2 times A. This is your separation. Please keep this in mind. Separation is twice A. This whole thing is 2A. 2A. Upon, what is there? R cube. Here, R is basically X. I think X is given. So this is basically your X cube. 2 2s are 4. 4 gets cancelled. So I'm left with Q and A, and here pi epsilon naught X cube. I think I have such an answer. Is it option A? Yes, it is. Option A. Very good. Excellent. So it's a beautiful question on 3D, vectors and Coulombs law and field. Beautiful question. Resolution. Dipoles is also there. Dipoles. Everything. Okay. Let's move on. The main concept was visualizing it. So The whole idea over here was that there were three fields. One was maybe like this, one was like this, and one was like this, all in one plane which is parallel to the plane of the board over here. So there, all were equatorial. Beautiful question. Okay, let's see how many of you can do this. It's a very interesting question. Again, multiple concepts involved. Capacitor is tomorrow. Raj Gupta, after the session, you should take your problem book. Start with easy questions. If you are done with easy questions, go with medium questions. If you are done with medium questions, go with PYQs. So that's the level of increase of difficulty level. How many questions you should solve? At least 50 to 100. You can start with bare minimum 50. Okay, for each unit, I'm taking blocks. Okay, if you notice, electrostatics, Gauss law, potential, everything, one block. Tomorrow's block will be capacitors, current, electricity. That's second block. Then next block will be magnetism. Next block will be EMI and AC. So block wise, I'm completing the units and the chapters. So you solve at least 50 questions up to 100 questions. Okay. And lots of PYQs if you're confident. If you're not confident, even if you solve 10 PYQs, it's okay. But solve. Few of them at least you solve, the easy ones. So the potential is given. The question is, what is the charge inside the thing? Now, I feel that since potential is given, maybe it's not so easy to understand. Maybe I will rearrange it and then figure it out. How? First, get rid of the potential like this. Electric field is minus dV by dr. So it is basically minus d by dr of this whole thing, which is ar square plus b. So it will be nothing but minus a, derivative of 2r, r square is 2r, derivative of b is 0. So it will be basically minus 2ar. Now the moment I see this, I clearly see electric field is proportional to r. Electric field is proportional to r. I know there is only one such geometry where electric field is proportional to r. If you can name it, I will be very happy. Where do you think, in which geometry is the electric field proportional to r? I know minus sign is there, it just says that it is opposite, that's all. Mir, you can try, but if you do not try, then definitely you will not get. If you try, yes, you can get it. Sphere, correct. So uniform sphere, uniformly charged sphere, uniformly charged sphere. Perfect. And let's see what's the formula of a uniformly charged sphere. The electric field was 1 by 4 pi epsilon naught q r by capital R cube. So I can do one thing though over here. I can just say q divided by 4 pi r cube and put r over here and epsilon naught over here. Reason why I'm doing this is because I will convert it into density. So because I want charge density. So here is what I will do. I'll just divide it by 3. Because I have divided it by 3, I also need to multiply it by 3 over here. So 3 gets cancelled. This is basically, what is this? What is this? This is your volume. And what is this whole thing? It is charge density. So it will be basically rho, which is your density, into r by 3 epsilon naught. That is your electric field. From here, import this value over here. What is the value of electric field from there? Just take it and put it over here. You will see it is minus 2ar is basically equal to rho r by 3 epsilon naught. R cancels. So rho will be equal to, check this out, 6 with minus sign. A is also there. Epsilon naught is also there. So that should be your answer. Done. And do I have it? Yes, it is there. 6a epsilon naught. What a beautiful question. Non-conducting sphere, yes, solid charge sphere. Very good, Harni, Amrita, Darshini. Very good, Goxter, Sriji, G aspirant. Excellent. Beautiful question, guys. Okay, let's move on to the next one. Okay, quite similar concept, but a calculative based question. The potential is given by this. What do you think is the field at 1 meter? J aspirant, I'm at my home in Bangalore. Shruti, it is interesting to see me solve, but when you solve, you get a headache. Okay, so Shruti, start with easy problems, bacha. Number 2, related to phenomena. Whenever you see formula, manipulate it, substitute values. The more you think, then you will love it. And the best way to love something, to fall for it, is basically start with the easy stuff first. Because if you directly go with the hard stuff, you're like, sorry, I can't do this. So basically, like, you know, if I have to learn painting, for example, I'm very bad at painting. If some teacher comes and tells me very difficult questions or give me a very difficult drawing or something which involves a lot of skills, reflection, God knows, some mixing of colors and so many concepts, I'll be like, I can't paint, sorry. But if the teacher gives me like, okay, today you draw a tree, tomorrow you draw a person, tomorrow you draw this thing, now let's draw more, let's draw shadows, let's draw light effects, slowly, then you like, okay, now I'm getting a hang of it. And you should practice. So when you practice, slowly you go into it. So that's how it is, okay? Come on, let's try and do this question, voltage. Because I've been solving for a very long time, Shriji, that's all. Okay, so let's figure this out. Voltage is given, field has to be found. There is only one formula which relates field and voltage, and that is basically your minus dV by dr. In this case, it is x, so I'll just put x over here. So basically, it is minus d by dx of 1000 by x plus 1500 by x square. Oh, why do we put it down? We can just put it on the top. It will be easier to differentiate this. So I'll just put it on the top, guys. Just 1 second. 1000 into x raised to minus 1 plus 1500 into x raised to minus 2 plus 500 into x raised to minus 3. This is what I'm going to differentiate. So let's try this out. So minus, the first thing, this will just become 1000 into minus 1 into x raised to minus 2 plus 1500, oops, so many zeros, sorry guys, okay, into minus 2 into x to the power minus 3, I'm using nx raised to n minus 1 formula, plus 500 into minus 3 into x raised to minus 4. This is what it is. Minus, minus, minus. With this minus gets cancelled, becomes plus. So it will become 1000 divided by x square plus 1500 into 2 is just basically 3000. So 3000 divided by x cube plus this is 500 into 3, which is 1500 divided by x raised to 4. Now the last pointer over here is substituting x is equal to 1. So if you put all these three values as 1, obviously 1 1 1 1, it's simple. So just add them, guys, it's very easy. So 1000 plus 3000 plus 1500, that's going to make it how much? 5500. And do I have such an option? Just check it out. Oh, I have two options now. Is it plus or minus? Be careful now. See, I have solved everything with sign convention. So basically it should be in the positive direction of x because the answer came out to be positive. So hence it should be plus 5500 I cap. Hello Bhargav, nice to see you back. If you're already in the NEET crash course, Dhanush, you're getting the Tattva in a modified form in the form of assignments. Because Tattva is huge. You can't solve everything in the last 1-2 months. So you have selected, handpicked the questions which you need to solve in the form of assignments. Okay, so you've got it as assignments. Yeah, only derivatives concept and dv by dx concept is here. If this was x, y and z, then what will you do, guys? If this was x, y and z, then each component you will differentiate separately. Each component will give you I cap, j cap and k cap separately. Here everything was x, so answer was in only one direction. If it was different, then I, j, k separate. HiPi, solving more and more problems. Lots of questions. Daily, you know what I used to do and what toppers used to do? They used to wake up. I'll tell you one true story. One of my friend, he's very good, okay? So I should not always give my examples. I should give you even better examples. So one of my friend, he used to wake up at 5 o'clock in the morning or 6 o'clock in the morning first 2-3 hours of the day, even with the breakfast and all of that, you used to solve lots of problems, as many as you could, 20, 10, 20, 30, and it became a habit. And then he used to understand, oh, where I'm going wrong, where I'm finding difficulty. Then the morning time, he used to spend time analyzing, studying, and then by afternoon, again, he will start solving some questions in a timed manner, because that's the time when you're always sleepy, and if you keep your mind alert, then you're also alert in the exam. He made it a habit. And then again in the evening classes and all of that, he used to attend, he used to do homework in between in the afternoon or anything else which is remaining, or sir had told to solve this assignment and come, he will do it and come. And again after the class, again he will revise whatever he did in the day and again solve some more problems. So this is the habit which students came across, and it has helped them, and they got all in the rank within 100. Okay, how about this option? Meanwhile, I'm pretty sure you would have solved this. X, Y, Z. Oh, it's simple. At this point and this point, you can see the closeness or the farness of the field lines is same, and it is low field over here. The field is low and it is equal, but here the spacing is less, density is high, so the field is also going to be high. So Y is the highest. I think that's option D, I guess. Yes, Drew and Drew. Meghaninandar Guru, the crash course for NEET is there in the description box. Right now when you are watching it only, you can see it. It's right over here. So in the description box, just go. See, NEET crash course. Just click on this link, it will open it up. And just, yeah, open it up. It's there in the description box. Moving on to the next one. The electric field between 2 points is constant in both magnitude and direction. Okay, so the electric field is uniform, like you can see. Consider a path length of D, this is D, angle theta, which is 60 degrees, with respect to the field. What is the difference of the voltage? Very good, Janaram. By the way, I think the crash course price will also increase by next week. So that's what we got. Most likely 99% the crash course prices are increased. I'm not just bluffing. Okay, it's very good chance that many courses are going to increase in price by this Sunday. Now, how do we do this? Well. We want to find the voltage difference between points 1 and 2. Field is there. Voltage difference. Well, let's try to think about this. We know that electric field is basically, minus dV by dr. But when you have uniform field, you don't need derivative. But when you have uniform field like it is over here, then you can just say electric field is minus del V by del R. You can just rearrange, and voltage difference magnitude wise is just going to be EdR. That's what you're going to get. Electric field into distance. Oh, sorry, not dr, delta R. My bad, because I was using delta over there. So keeping this thing in mind, which is basically a manipulated result of this one. It's a manipulated result of this one. That's number one. Number two, to find the voltage difference between points 1 and 2, I will try to simplify the path, because directly maybe it is not easy, but indirectly, yes. How? Instead of directly going from 1 to 2, first go from 1 to 3 and then go from 2 to 3, 3 to 2. So the voltage difference between 1 to 2 is voltage difference between 1 to 3 plus voltage difference between 3 to 2. This is basically, it is independent of path. It is independent of path, and this property comes because of some nature of the field. What is that nature called? Let me know in the chat box. The field is said to be dash, hence the work done, potential changes does not matter on the path. It only depends on the initial and the final path. What is that property of the field called? Let's see how many of you remember this 11th standard concept. Conservative. Very good. It is conservative in nature. Very good. Proud of you guys. Now just add them up. Voltage difference between 1 and 3 is field into R. Field is E. Distance is obviously D cos 60. So D cos 60. Next thing, what you should realize is the voltage difference between 3 and 2. Do not forget that 2 and 3, if you continue that line, this is nothing but an equipotential line. Third concept. perpendicular. This is field perpendicular to potential. So all the points are on the same potential. So exactly, yes, V32 will be 0. All are on this equipotential line. Keep this in mind. So that's it. So that's the answer. ED cos 60. Do I have it somewhere? Yep, it is. There is also another way of looking at it, even if you don't go by equipotential line. Also bear in mind, like you can use this. It's actually electric field dot distance vector. There is a dot product here. So the magnitude. So if you see electric field is here, the distance is like this, the angle is 90 degree. So cos 90 is 0. So that way also this comes out to be 0. So technically it is dot product. Please bear that in mind. Yeah, Janaram, it's slightly less, I guess. But there are weird questions which they ask. I don't know why. Okay, moving on. How many problems I do daily? Hi Pi, apart from the problems I discuss in the class or the doubts or whatever class notes, that's all. Yeah, so whatever I solve is over here in front of you on YouTube, or my daily classes which I'm taking on Crash or the 12th standard batch or whatever courses I'm designing, or basically checking some doubts, whatever. So I don't know how many problems, at least I'm guessing 50 problems, 40 problems, yeah, per day, at least, yeah. Sir, any guess for KVPISX cutoff? No guesses, bacha. It was difficult, that's what I heard. Okay, so QQ minus 2Q, and let's try to solve this on an equilateral triangle. So let's draw an equilateral triangle. So what do we have? QQ minus 2Q. Q minus 2Q. Find the magnitude of the dipole moment. Option C says Darshini. Find the magnitude of the dipole moment. So first thing what I'm going to do is make dipoles. So instead of minus 2Q, I'm just going to write it as minus Q here and minus Q here. Now you can see that you have got two dipoles. Dipoles always go from negative to positive. So this is one dipole, you can see that. And there is also another dipole right over here like this. So these are your two dipoles. So this dipole P1 will be charged into the length. Length is how much? Side L. So P1 and this is also P1. The angle between them is 60 degrees. So obviously you're going to take the vector sum of them. So let's take the vector sum. So the net dipole will be root of P1 square plus P1 square plus 2 P1 cos 60. I'm using vector addition formula, that's all. P1 just comes outside, and in that root you have 1 plus 1 plus 2 into cos 60 is 1. Cos 60 is half into 2 is 1. So P1 is basically QL. 1 plus 1 plus 1 is root 3. So QL root 3 is the answer. C for Capto. Yes, again. Wow, what is the bias towards C today? Yep, option C it is. Very good. Hi Pi, it depends. 4 hours in one subject. If you are learning something, then it is fine only. Even if you solve one problem in 2 hours, it's okay if you are learning something. But as you progress, then you should solve more and more problems. Obviously, you cannot expect one problem per 2 minutes, which is the speed required in JEE Mains. That speed only comes when you sit for mock test. Otherwise, even if you are taking 5 minutes per question, 10 minutes per question, it is fine only. Next question. Two spheres, same radius, one hollow, other solid, charged to the same potential. Which one will hold more charge? Which one do you think will hold more charge? Think about it. Two spheres, two copper spheres, same radius, but remember, one is hollow, one is solid, same radius. Which one do you think will hold more charge? Oh, is there a bias again? All right, hollow, the charges can be only on the surface, and the voltage will be given by K, Q divided by the radius of the shell. In a solid also, in case of a solid also, we know that the charges can only be there on the surface. Inside, remember this, in a conductor, in a conductor, the charge is 0, field is 0 inside a conductor. So again the formula will be again KQ by R. You can clearly see it is given in the question. Same potential. That means V is same. If V is same, obviously Q should be same. Hence, both will hold equal charge. That's it. Done, done, are done. So potentials are same, hence charge will be same because radius is also same. It's also given that over here that the radius is also same. Else that could be different. Very interesting. Wow, we have a graph-based question. Hi Atul, nice to see you. Welcome to the channel. Velocity V by an electron after you started from rest and moved through some potential difference. Which graph is the best representation of this? Bias means partial. Kalyani, like say for example, I am biased towards somebody. Let's say I'm biased towards you. That means I favor you. You do something wrong also, I'm like okay. So that's the meaning of bias. I hope that is clear. Okay. C again? No, it is not C. No, Suman, it is not C. Let's see how this question has to be solved. You have to accelerate an electron through a potential difference V, and it will obviously acquire some velocity that is given by charge into voltage difference is half mu square. Therefore, u square is equal to 2q divided by m into delta V. Now, this is the formula which I'm going to look at. And hello, Harish. Now you need the knowledge of graphs, that is maths. If this is y, this is x. When I say y is equal to some constant into x square, it's a parabola, u-shaped or inverted u depending on the constant if it is negative. So it will be basically like this, correct? It will be basically like this. But if I say y square is equal to some constant into x, then things change. The graph will be basically like this. Now you only see over there and you only decide velocity and potential difference. Velocity and potential difference. This is going to be basically your y-axis. This is going to be your x-axis. You guys decide whether it will be u, inverted u, straight line, C-shaped. Obviously, from here, you know what the answer should be. Oh, is it Jana? What was the reason? Please let others also know, because it's very important. Others, maybe 11th standard student or some other students also realize from your learnings. It's very important. Yep, it should be D. You can see that right over here. This graph. That's how it is. Correct. So maths, you cannot forget in maths paper. You have to remember it in physics also. Okay, so we have a Gauss law based question. Let's try to solve this. Yes, Atul, you can ask it. If it is related, I'll definitely answer. The flux for a Gaussian surface A is to B. Actually, this is A is to B. That encloses the charges. Q1, Q2 is inside B. Q1, Q2, Q3 is inside A. You can see that where it is. In the free space is given by charge values are also given. What is the ratio of the flux? So if you're wondering what is the question, flux of A upon flux of B is how much? How much is the flux enclosed by A upon flux enclosed by B? Oh yes, Kalyani, you two are senior. And soon you guys will be ex-Vedans. And soon you will be college people. And then people will look up to you. Oh my God, how did you guys get in? How did you study? Please tell me. It will be amazing. And so that's why you have to work really hard so that you can tell your juniors. You can tell your junior cousins. You can tell your society bacha parties. See, this is what I did. You guys, please don't do this. I did this wrong. I wasted my time like this. Don't study from this book. Don't do that. Don't do this. Yeah, very important. A, is it? Let's try to figure this out. First of all, phi A by phi B will be nothing but charge inside of A by epsilon naught upon, this is charge inside of B by epsilon naught. Epsilon cancels. Now the charge inside of A which is this big surface, is 1, 2, 3, all the three included. So it will be Q1 plus Q2 plus Q3. Whereas if you talk about B, only 1 and 2 is there inside, so it will be just Q1 plus Q2. So let's start substituting Q1, Q2, Q3. So minus 1 plus 2 minus 3 upon 1 and 2. So it is minus 1 plus 2. So this will be minus 4 plus 2 is minus 2. And this will be nothing but 1. So it will be basically minus 2. Just check this out. Is that, yay, it is there, option A. Beautiful. See, without the minus sign is also there. A lot of students can make a mistake over here. Many students. Bye. Why are you saying bye to me? Why are you saying bye to me? Okay, cool. Let's do the next question. All right. So, beautiful question. PYQs. Hi, Rohit. Yes, Amrita. Yes, draw and draw. It is option A. Electric field at the center of the semicircle of radius A having linear charge density. Somebody had a doubt. Maybe was it Sriji or something? Who said that, sir, arc related problems, how to solve it. I just given you a formula. If you had an arc, then the field is given by 2k lambda divided by r sine of theta by 2. Remember, this was the formula. Yes, oh, I remember it. So let's try to solve this question. This is also an arc, linear charge density, radius is given. Let's use this formula as it is. Always the field acts along the complete angle bisector. The complete angle bisector, this is where the net field will be. So the net field will be, let's try to do this, 2 times k. So 2 into 1 by 4 pi epsilon naught into lambda by r, radius is basically a, into sine of the angle. Now if you notice, this entire angle is 180. What is the total angle subtended by the complete arc? So that's what it is. So it is 180 divided by 2. So this will be basically equal to, let's try to do this. 2 2's cancel. So 2 pi epsilon naught 1 lambda a sine 90 is basically 1. Makes sense, right? So that should be the answer. Do I have it somewhere? Oh, again, see guys, what is this? I should tell my content maker, please choose other options. I think C for captain. That is how it is. C for captain. Very good. Now I hope you guys understand how to use this formula in questions as well. This was a PYQ, by the way. Thank you, Rohit, so much. Okay. So, the concentric spheres of R and R have similar charges with equal surface charge densities. Sigma, what is the electric potential at the common center? By the way, I was not at all fluent in English when I was in school. I was horrible. It has improved slowly. I am not maybe the best, but slowly improving because of continuously talking, reading, watching, listening. Yeah, that's how it is. So you guys too. The concentric spheres of radius R and R, similar charges with equal surface charge densities. Sigma, what is the potential at the common center? Let's try to visualize, draw the situation. Okay, so concentric spheres, so maybe like this and like this. This is one radius, this is other radius. The question is, what is the voltage at the center? Now, okay, let's try to figure this out. So the voltage at the center due to same charge densities. Okay, I think what we can do is, I can say it is because of the shell of radius R as well as R. Both the shells have charges. Both the shells have charges, and each charge on that shell will give rise to some potential at the center. It will definitely give rise to some potential at the center. So let's try to figure it out. So it is potential due to R plus potential due to the bigger one. So due to the small as well as the big shell, both. What is the formula for potential? KQ by R. Okay, so put it up. So K Q by small r plus K capital Q by capital R. Oh, but the charges will be different. So maybe I should put different symbols right over here. So let me just do something. So how about writing K as 1 by 4 pi epsilon naught? So that will be better. So 1 by 4 pi epsilon naught Q by small r plus 1 by 4 pi epsilon naught capital Q by capital R. I'm not liking it because sigma is there. So how do I get it, or how do I get sigma? So charge is surface charge density into area. So this is the concept. Sigma, which is the density, is basically the charge per unit area. So charge will be sigma into area. So just substitute, instead of charge, you write sigma into area. Area will be 4 pi r square. Here it will be sigma into 4 pi capital R square. Rest of the terms will be as it is. So 4 pi epsilon naught small r, and here also 4 pi epsilon naught capital R. A lot of things cancel, 4 pi, small r. So I think I'll be left with sigma r by epsilon naught, and here sigma capital R by epsilon naught. And now we know what it is. It's option B, of course. B for Bombay. Hi, Buddy's Kitchen. Welcome back, JEE aspirant. Hi. Hello. Berlin, you want sure shot NEET 2022 questions? Yes, definitely. After the mock test and after the superhero series only. But let me tell you, a lot of questions do come from zero to hero, zero to superhero. Even my previous playlist of zero to hero, you should watch it. Last year in the mains exam, many questions came from my one shot series of, zero to hero series. So watch that as well as zero to superhero. Do I not need to integrate? Nah, I don't need to integrate, because these are just concentric spheres with equal surface charge densities. No, it's not there in between them. There is no charge in between. They're just two shells. It's not distributed at different radius. If it was, then I had to integrate. It's not uniformly distributed. Wow, Shriji, I'm proud of you. I want you to say the same thing after JEE, NEET, CUET, BITSAT. Everything should be rocking, and you should tell the same thing when we do counseling. Oh, by the way, guys, we do counseling on this channel. I will be doing soon for the 10th moving 11th kids. In case you have any, you should recommend them. But also, when you get colleges, or when you get your marks, reports, and all your results are out from all the entrance tests, you're confused. Which college should I go to? What should I aim for? We do counseling live, as well as all the kinds of things that you should know: branch versus college versus place versus package versus everything on this channel. Okay, so here's the next question. P by Q again. A square surface of some meters in the plane of the paper. There is a uniform field is also in the plane of the paper. Lower half only, so the field is only there in this part. What is the flux in this lower part? Come on, very easy, very easy. Rishabh saying D, Shriji saying D, JEE aspirant saying D. Hello FIFA mobile gaming. Yes, zero it is. Look at this, zero, because what did I tell you? If it goes in, it is negative. If the field lines come out, it is positive. Whatever is going in is also coming out. If it is so the net will be zero. In is going out. As simple as that. Done, done, done. Next question. Next question. Charges are there, plus Q and minus Q at points A and B. So this is plus Q, this is minus Q. And I think the distance is 2L. So this distance is 2L, and is C the midpoint? Yes. So this is L, this is L. If this is L, obviously the radius, this is also L. How much is the work done to move the charge Q from this path, CRD? So you are taking this charge and moving it like this. So in this path, what is the work done? First thing that should enter your mind, work done is basically, what is the work done, guys? Sorry, work done. The work done, I have told you, is delta U. It is basically U final minus U initial. Number one. Number two, it is independent of the path. So this semicircle has no role to play. Reason? It's a conservative force. It's independent of path. Like you can see, it only depends on the final and the initial states. Let's try to do this now. Yeah, there is no piercing. Oh yeah, that way also. Oh, I forgot. In the previous question, it was a 2D object. If it was a 2D object, there is nothing which is cutting through it. So there's no piercing. Yep. So there is no flux. And even if it was a cuboid, still the answer will be zero, because whatever comes in will also go out. Either ways it will be 0. Yes, 3G, very true. Okay, now final minus initial. So let's talk final first. Okay, let's talk final first. So this is final point. Now when you're here, the potential is because of this guy, which is this charge over here, as well as this charge, which is at a distance of 3L. This is L. So because of them, how much will be the potential? Oh, potential difference, or I do not know. Hold on. I'll just do one small thing before coming here. Just 1 second. This can be also written down as charge. Now the charge that you are moving, which is the charge? Where is that charge? Oh, you are moving this charge. You are moving this charge. So I'm just going to write it as Q into final voltage minus initial voltage, right? It's the same thing. Energy difference is charge into voltage difference. Okay. Now let's try to do this. So this is my final voltage at this point. Okay, so what will be the final voltage? Think about it. It will be this charge's potential here, which will be K Q divided by 3L. This charge's potential here, which will be K Q, but oh, this charge is negative. So I need to put a minus sign here. Minus, oops. I'm so sorry guys, 1 second. I need to put a minus sign over here upon the distance, which is L. So this becomes your final voltage at this point due to this and this, both the charges. That's it. Q will come as it is. There is no change in that. Next thing, we will talk about potential at the initial point, which is right over here. So it will be because of this guy as well as this guy. So it will be nothing but K Q divided by L, and that is also K but minus Q divided by L. So that completes it. Now you know this term is just going to be 0, right? So that's going to be 0. And what is this going to be? I think you can say 1 by 3 minus 1 is minus 2 by 3. So minus 2 by 3 K Q by L, and this Q is just as it is outside. So this will become Q into minus 2 into K, which is 1 by 4 pi epsilon naught into Q divided by L, and the 3 comes from here. So 2 and 4 goes, like you can see right over here. 2 and 4 goes 2 times, 3 2s are 6. So I should have 6 in the denominator. Where is it? With a minus sign. That's option C. Q is there? Yes. Small q is there? Yes. 6 is there? Yes. Pi and epsilon naught and L are there? Yes. Option C it is. Very good. I was in WION News. Really, yo? I was in WION News. Are you kidding? About startups, like what was there? What video you saw? I'll probably discuss with you after this session. Okay, hold on, just few more questions to go. Let's see the next question, guys. Few more questions only. Two electric dipoles of moment P and 64 P are placed in the opposite direction on a line which is separated by 25 centimeters. Okay, electric field will be 0 at some point. Okay, we need to think why. The dipoles whose distance from the dipole moment P is how much? Okay, was it an ad? Bacha, maybe I'll discuss. Hold on. And now I'm also interested, but not now. Hold on. This is 64P. Given that they are in the opposite directions, so that's how it is. And the separation between them is 25 centimeters. Dun. Now what we will do? Well, there is a point somewhere where the field is 0. Okay, so let's say this is X. In fact, they have asked you to find the distance from the dipole moment P. What is the distance? That's what they have asked. And obviously this will be 25 minus X. At this point, you will see that the net electric field is 0. They have asked you what is that value of X. Sure, you can do that. Now, I have a feeling this is a question based on field due to a dipole, and that too, this is an actual point. You can see this whole thing is an axis. This is basically axis. So due to this dipole, the field will be here. Due to this dipole, the field will be here. Both will cancel. So the axial fields due to the dipoles will cancel each other. They will cancel each other. So let's try to figure that out. The field due to this dipole will be 2 times k into p divided by this distance is x cube. Due to this dipole over here, it will be 2 times k into but 64 times p divided by that distance, which is 25 minus x whole cube. If you forget the cube, you'll get a wrong answer. Now solve this. 2k goes, pp also goes. So you will be left with 25 minus x whole cube is equal to 64 into x cube. So take roots, cube roots on both sides. So 25 minus x is equal to 4x. So therefore 25 is equal to 5x. So therefore x is equal to 5. That's it. Everything was in centimeters. So I bet everything final is also in centimeters. There you go. Done. So concepts used were field due to a dipole, second vectors and basic geometry. That's all. So if you start drawing, if you start writing, if you start marking what is known, what is not known, then you start getting an understanding of the question. Let's see the next one. Very good, draw. Very good, Rohit. Sorry, is it Rishabh Upadhyay? Yes, FIFA. It is 5. 2 spherical conductors of radii 1 and 2 are separated by some distance. They are charged. Now they are connected. Then they are in equilibrium. So the charges will get distributed. What is the final ratio of the magnitude of the fields on the surface? Wow, so many things are happening. Let's try to understand. So there are 2 spheres A and B. This is 1 millimeter. This is 2 millimeters separated. 5 centimeters is very large. So basically this is very large distance between them as compared to the radius. It's very small in millimeters. Now you connect them. So you take this sphere and you take this sphere and you connect them. So what happens? Potentials become equal. So V becomes equal. So the whole thing becomes one conductor. All of it is a single conductor. That's how it behaves. Remember, this wire, the sphere, everything is a part of one single conductor. Charges will realign. Now the question is all about what is the field on the surface. What is the field at this point and this point. Now if it's a single conductor, I know one thing about a conductor, guys, and that is the charge distribution and the field depends on the radius of curvature. As in, if you have a sharp object like this, at the sharp point you will see the charges are more, hence the field is also very dense, and over here you will see the field is less. In fact, the field is proportional to the density, and that is inversely proportional to the radius of curvature. Big radius, it's smooth, big, then you will see field is less. If it's sharp, R is less, field is higher. Use this concept over here, you will get the answer. Because it's one single conductor, EA by EB will be RB by RA. So RB by RA, which is 2 by 1, that's the answer. 2:1. Do I have it? Option C, yes. Some of you might make a mistake and write 1:2, but that's not correct. Option C, oh my god, again C for Cap 2. There's some bias towards C today, but ignore that. Okay, beautiful question. Hi D Pratibha, welcome to the channel. All the new warriors, do not forget to hit the subscribe button. And if you're already subscribed, you know what to do. Your Guru Dakshina is always smashing the like button. Should not watch anything for free. Okay, chalo, let's move on. Oh wow, we have a homework question. I have put up the solutions on the next slide. I cannot show it to you right now. It will be there as the PDF put up in the Telegram. Okay, where do you find the Telegram? I'll show it to you. It's there in the description box. A lot of other things too in the description box, like the JEE crash course, NEET crash course. NEET crash course 120 sessions because bio and zoology is there. You also have the JEE crash course for 90 sessions with doubt solving, and also all India rank test series full part including assignments, and the recordings are available till the last day of the exam. It's not 3rd July, it's till last date, till the last date. And even I am teaching in the crash course physics. Yeah, you will find me over there. Imagine solving so many assignments from so many chapters with so many questions. You will be completely occupied. And the best part is the crash course is just for 2,700 bucks. Although the crash course has started already, there's no point watching it just live, because you might have studied some chapter or you are just in a hurry to go through all the concepts. Watch it in the recorded way. Skip the parts which you already know. No need of watching it. And all our recordings are interactive in nature. So while you're watching this video, you will see in the description box, JEE crash course, NEET crash course. You click on the NEET crash course, you will see all the details about it. And you can see the price is 2,700, 120 classes, 5 weeks. Same way over here, the JEE crash course, click on this link and you will see buy course. You can click on this. You will see coupon code gets applied, SHPRO, multiple payment options, of course, and you have saved a lot of money. Make sure you enroll it as soon as possible. Yes, Rohit, I'm in Bangalore. And thank you for liking, guys. It means a lot. Can I join the JEE crash course now? In fact, now is the best time you can join it. If you delay it further, one, price rises. Number two, very little time left before your JEE mains first attempt. So it will be useful for your first and second attempt. I would say give the mock test in it when the JEE mains is closed, but solve the assignments. You will be very busy solving the assignments. I'm so glad, Darshan, you enjoyed. Thank you so much. And guys, you know what to do apart from the chat box comments you leave. Always leave the comments in the comment section after the video is over. It means a lot for me. Thank you very much. And where did that Om or somebody went? He said that he will share me the link. Where is that link, bacha? Please share it with me. Bye bye, Amrita. Take care. Thank you so much, Lakshmi. Studying for 12 hours and 4 hours per subject by your motivation. Oh, 4 hours per subject. Very good. High pi. Nice. You should probably high pay. Is it pay or pi? Oh, pay. Okay, fine. Good. Keep it up. I like it. Excellent. Bye bye, guys. I'll see you tomorrow for capacitors and current electricity. And please solve lots of questions, lots and lots of practice. Make mistakes, learn from it, and come prepared for capacitors. We'll have a mind map, revise, and then solve more questions with PYQs, of course. Bye bye. Have a great time. Previous class recordings, it's all there in the playlist, bacha. So just go to, yeah, this is the playlist. Just go back here. See playlist. See all the playlists. 0 to superhero, chemistry, physics. You can see view full playlist. You will get all the chapters which was done previously. Even if you want detailed classes, that is also available for you. Thank you very much, guys. Take care. Have a great time. Hasta la vista. Bye bye. Signing off. This was Shreyas here.